Hello everyone, my name is Sylvain Rochon. I'm getting people to expand their human experiences using cutting-edge technologies. That's what I do, and here's a new video. Today we'll be talking about new materials that can be used in a lot of different ways to resolve a lot of different problems we have on the planet, and also they're really cool. Now the reason why I'm talking about materials instead of I guess direct applications of technologies is because materials are, plastics, paper. They're essentially bits and pieces from which we make devices, equipment, food products, whatever it is you need, right? We build things with materials. If such materials have very interesting properties that are really like what we would call quote-unquote space age, then we can do really cool things that are really like science fiction like. And in the last few years, we've seen some pretty interesting things happening. We've seen like the use of more carbon nanotubes. We've been seeing the use of graphene and even more usage of graphene. Just by the way, graphene is a material that is about 200 times stronger than steel, a lot lighter. It conducts electricity, and it has all sorts of other properties that are really crazy. So that's a material, and then you can use it and to do some other things. Oh, graphene is also transparent to boot, so you can make glass with it, even though it's not made out of glass. Anyway, other materials that are cool like that are being researched and being used in laboratories and going into applications, which means people that are building stuff can start using those for different applications for whatever, because of whatever properties the materials have. One of them, which I think is the most interesting, is the Wolverine material, and that's making reference to the Marvel character Wolverine that regenerates. Now this is a material that is essentially transparent. It can stretch. And it's an ionic conductor, so it can be used to change properties using electricity and using ions. But the most interesting part of it, if it's ripped, scratched, or damaged in any way, and it's not too severe, it's going to repair itself and it's going to keep its properties. It's going to go back to its original form, even though it's not a liquid. It's essentially a solid, and you can flexibly apply it somewhere. It's like an elastic. And the most interesting application I was thought of is to use that to make muscles for new age robots. Use electricity to expand and contract the material, and if it gets damaged, well, guess what? It's going to self-repair. So that's really cool. Second material of interest is a little film that is also transparent that you can put on pretty much any surface, and by touch generates electricity. So you can apply that to, for example, smartphone screens. And as you use the smartphone, you're generating electricity as you're consuming it because of the light and whatever the smartphone does. So your smartphone battery lasts a week before without recharging instead of just lasting a couple of days, or it could last longer. If you fold this film several times, then it multiplies its electricity generating capacity. So instead of being used as a film, it can be used as like a thicker material that can be interacted with, and it generates more and more electricity. So it has multiple uses across lots of different devices. As long as it's being used in touch, it's going to generate the electricity. So less battery use, less consumption of electricity from different sources. And the third material that I wanted to mention in this particular video is a little material that is absolutely engineered using organic compounds. So it's biodegradable. It's just like body compounds, actually carbon, nitrogen, oxygen, hydrogen. And I think there's a little bit of zinc sometimes that are put in those. And they're engineers with pockets that are able to capture selectively certain molecules and excluding others. And they're currently they've been tested very successfully, like 99% effectiveness at capturing heavy metals, which are terrible for human health, from water. without capturing the other materials that are inside the water. So get the bad stuff out, keep the bad stuff in. And these materials can be recycled several times without losing any amounts of efficiency. So you can just like safely use them into a water supply, capture all that heavy metal, and they will phosphoresce. So they're going to generate light when they do their job, when they detect there's heavy metal. So they have double use. And these are like, essentially some people will call them intelligent materials, but they're just engineered to do these things. So we're getting really, really smart. These properties can be used in a wide variety of ways, not only in detoxifying and different things, but I can see a usage perhaps in the human body if you want to remove some poison that's in a body, for example, selectively choosing that particular molecule, excluding everything else, so you can safely remove something that's inside a person's veins, for example. And a slew of other applications can be used. And these are little materials that can be used in multiple applications that are really, really, really cool. So don't always think about opportunities being the actual devices. Sometimes it's actually the materials that give way to a large amount of advancements and a wide variety of applications and services and devices and all this stuff. So keep an eye on materials, guys. This is a great, great field to keep an eye on and invest in and look into for whatever you're trying to build. And that's going to be it for today. I think that's enough for you to think about. The links of those materials I mentioned are below, as well as my blog where I describe a little bit more in writing what I just talked about. Enjoy, and I'll catch you next time next week.